yesterday. Would anyone in this class say that negative numbers are silly and we shouldn't have them, we shouldn't use them? Would anybody say that's true? All right, okay. Somebody's like, I do, but I'm not going to speak up. Oh, you can just go join the flat earthers if you want. So I think all of us would agree. Negative numbers obviously are important. We need them. Sometimes we get them when we don't want them, like in our bank accounts, stuff like that. We need them. We need the idea of negative to solve things, like we were saying. So then eventually it came to be understood and came to be accepted. This is like I was telling you the other day. They were called imaginary for a while, or impossible, or whatever, until eventually people kind of were won over. And then the idea of square root of -1 never kind of got accepted fully. So that's why it still has that word imaginary attached to it. So in reality, now here's something that they didn't talk about in this. I can't remember if they eventually talk about this. But this is kind of cool. I'm going to do one little thing with you right here, and then we'll get into some specifics about what we got to worry about. When you multiply, let me put another thing here. When you multiply by -1, if I have 1 and I multiply by -1, do you see how that's a full 180-degree turn? Does that make sense to say a turn? If I have -2 and I multiply by -1, where do I go? I turn by 180 degrees to there. Does everybody kind of get that idea? You've probably never looked at multiplication like that, but that's multiplying by -1 is a turn, right? Let me stop there. So what if I wanted to make a half turn? I should be able to do that. If I can make a full turn, I should be able to stop here. That's what these are. So what would that mean? If I take a half turn and then another half turn, So 1 times -1 is a 180-degree turn. It is. You with me? Okay, I like it. But let's say I want to go halfway, and then halfway again. Whatever that thing is, let's just call it I for right now, forever. If I multiply by I turn halfway. If I multiply by I again, I turn halfway again, and I end up back here. So that would mean that I times I is -1. I squared is -1. That's really what it is. And that's part of the thing that you guys never get to see. I don't even know if this fully made sense. Hopefully it made a little bit of sense. One way you can look at multiply by negative, and I've said this before, is you go to the other side of the number line. In fact, I did this because I was trying to get you ready for this. So if I can turn 180, I should be able to turn 90 degrees. And there is something that exists. There's this guy. So when he was lifting the thing out of the paper and it was becoming all this multicolored stuff, right? That was the number line, and then this was coming in and out of the paper. This other stuff here. This I stuff, this square root of -1 stuff. Okay. Let me bring it back down. I just want to tell you all this just to give you the real background of what's really going on. Now let's focus on what you really bare bones have to worry about. Just in case you're like, oh shit. I really love this idea of turns though. In fact, let's do this. All right. So I is the square root of -1. Because I times I is -1. If we want this I to represent a 90-degree turn, then doing it twice has to have me end up here if I start at 1. That's all there is to it. It has to. Okay, I like it. So what would one more turn do? This is I here, right? And so this would be 2I, and this would be 3I. Is that cool? It's just the I-axis. Right? This is what they meant by lateral. What does lateral mean? Who works out? If you work your lats out, what's that? Anybody work out at all? No? You're all like, no. Your lats are your sides, so lateral means side, right? If you're into biology, you have lateral fins or lateral movement, move to the sides. So it's to the side of the x-axis. That's why their lateral numbers are much better than imaginary numbers. Right? It's bullshit. So watch this. What's down here then? What's this and what's that? What would this have to be? Negative I. -2I. So forth. So if I take 90-degree turn, that's I. That's this. If I take another 90 degrees, that's I squared. I did it twice. That's this, right? If I take one more, that would be I cubed. Where do I end up? negative I. And if I take one more, what's I to the fourth? 1. Okay. All right. Now don't worry. We're going to do that again because this is the part that you really have to know. I'm going to show you this in a little bit different way. But I wanted to stick with this idea of turning because then actually if you think about it as turning, it makes everything make a lot more sense. They're not stupid imaginary numbers. They're just letting you turn halfway through. Okay. So let's come at this from a different angle. If you don't like this visual here. Because this is the way it's not normally shown, which to me is dumb. This is the real idea. Here's the way it's normally shown. You say, we define I to be the square root of negative 1. Sort of like we define pi to be 3.1415, blah, blah, blah. We have this gross thing and we give it a letter, so we don't have to look at the gross thing. Square root of negative 1 freaks us out. Let's give it a letter, so we don't have to look at the gross thing. You guys still with me a little bit? Therefore, I squared, will any marker work for me today? I squared would have to be square root of negative 1 squared, right? If I define this to be this, then I squared has to be the square of this, and what do you get? Negative 1. I like it. So finally, there's something that when I square it, I get a negative number. And that's this idea of lateral numbers or imaginary numbers. And then I cubed would have to be I squared times I. Is that cool? Right? I squared times I would be I cubed. Why do I do that? Because I know what I squared is. What's I squared? Negative 1, so I get negative I. Right? I cubed is negative I, which is what we got earlier by looking at it as terms. But now I'm looking at it as just exponents. And I'm getting the same shit, thank God. Oh, some of you guys want to hurt me, it looks like. All right. I to the fourth would just be I squared times I squared. Is that cool? And I squared is negative 1. So I get negative 1 times negative 1, which is 1. Bless you. All right, now watch. What about higher powers? Do you see what happens if I go to I to the fifth? Stay with me now. You'll start to realize these are the only 4 things I have to know. Because what would I to the fifth be then? It would be I to the fourth times I, wouldn't it? Right? And what's I to the fourth times I? I, because I to the fourth is 1. So it's going to repeat. Right? Yeah, exactly. I to the fifth is 1. I to the sixth would be I to the fourth times I squared, which would be 1 times negative 1, which is negative 1. So I, negative 1, and it just keeps repeating. What's really beautiful is, so this is what we call cyclic. It's cyclic, right? There's a cycle to it. And every fourth one, it kind of starts over. Right? So now watch this. Let me see. Yes?
Can we do I cubed times I cubed?
Yeah, totally.
So it doesn't
Or I6 equals I cubed times I cubed. And what's I cubed? Yeah, so it would be negative I times negative I, which is I squared, which is negative 1. Same thing. Yeah. Yeah, so any way I think of breaking the exponent up, so I can base it on stuff I already know. So if I want to investigate I6, I break it up into smaller parts, each of which I know. Does it matter which way I break it up? No. If I do I times I to the fifth.
What if it was negative I squared?
Oh, you mean like this here?
Oh, yeah.
Right? And that's basically what we just did. Right? Yeah. I like it. Okay. So this is what I'm trying to get out of this little thing. This is one little tiny thing you got to know, is how to do higher power i's. Right? So can somebody tell me, how would you figure out what I to the 40th is? Say again?
Back to the 40.
Negative.
No. So watch this. I to the 7th would be
Be negative 1.
negative I again, right? And I to the 8th would be 1 again. I to the 7th would be I to the 6th times I. It's negative I to the 8th would be I to the 7th times I. It'd be negative I times I, negative negative 1 is positive 1. It just keeps repeating all the same outputs. It starts over. Why does it do that? Because it comes back to 1.
So you still have to like divide it by 4?
Yes, every fourth one, it goes back to 1. So if the power is evenly divisible by 4, the answer is 1. I to the 8th is 1. I to the 12th is 1. I to the 16th. So I to the 40th is 1. So what do you do if it's not something like that? What do you do if it's I to the 83rd? Well, 4 goes into 83. Who cares with what remainder?
3.
Then you're here. Bam. The remainder tells you where you are in the cycle. That's kind of nice. And again, why does it keep repeating? Because like you just said, it's a freaking circle. Right? It's going, oh my God, oh shit, I already said all this shit. You know, oh, and this is just a bunch of turning around a circle. It's going to eventually end up on one of these 4 things. Maybe you get that. So again, you can look at this I80 times I cubed. So you can even think of it like, I'm breaking it up into something 4 goes into and the rest. Well, that's 1. And I cubed is negative I. Right? So you just have to know these 4 values. I is I. That's crazy. I squared is negative 1. I cubed is negative I. And I to the 4th is 1. And then it starts over again. Multiply by another I, you're here. Multiply by another I, you're here. Blah, blah, blah. Starts over again. Starts over again. Because it is that turning. That's all it is.
So it's easily divisible or evenly divisible by 3. It's always negative I.
Nope. No, no, no.
But that only works for 4.
Yes.
Okay.
Because every 4 it starts over. The remainder, once you divide by 4, tells you where you are in the sequence. Is the cycle determined by 3? No. It's determined by 4.
Okay.
So why is this the same thing as I cubed? Because it has a remainder of 3 when I divide it by 4. So when I divide by 4, I'm just taking out all the repeat circles and just seeing where do I really end up. Okay. So how would I do this? I to the, what you got, Jeff? Nothing too crazy. I to the 17th power.
Negative I.
Well, let's see. It's I to the, well, what does 4 go into? Well, we can do it two ways. 4 goes into 17, 4 times with. So it's the same thing as I to the 1st, which of course is I. Right? Or you can do, this is I to the 16th times I. That's 1, so the answer is I. Yeah, I like it. So it's just a fact of just wrapping your brain around the idea. Right? That's what you got to do. Okay, so that's one little piece. This. And then you just see where you are based on the remainder once you divide by 4. Because every 4th one, it kind of repeats. It starts over again. I like it. Just to show you one other way to do this. If I had I to the 18th, isn't that I squared to the 9th? What was I squared? Negative 1 to the 9th. It's negative 1 still, right? There's an odd number of negatives. It's still negative. So you can kind of base it on I squared. That's another method I've seen used. I like the freaking, what's the remainder when you divide by 4? Because that's quick. And then you get the answer directly instead of having to do all this little work. I'm a little lazy. Okay. So that's enough of that idea, I
Is
think.
that positive I or negative?
This is definitely positive I. Right? Because it's I16, which is 1,
Okay.
times I to make 17. So it's 1 times I. 1 times I, of course, is I.
What would break it down to I16? I mean I15 and I squared.
Well, then I15 is not something that I know directly. You see, I wouldn't break it down like that.
Alright.
What's something I know directly? Any multiple of 4 makes it become 1.
Okay.
That's why I break it up into something that 4 goes into times the rest.
Alright.
Which, if you think about it, is exactly the same as what's the remainder if I divide by 4. Same thing. So the methods are really the same. This is the only other different method, but if you like this method, you can use it. Okay, if you don't like any of it, it's too bad. You got to know something, right? Part of me just hopes to God you guys are at least a little interested in this. I mean, we created numbers. This is true. This is a part of it. This is something you don't get to see that often. Some of you guys have maybe never even seen this. I don't know. But this is just a part of how our numbers work. You should want to know. I'm a freaking human. I should know how our freaking numbers are that we made up, how they work. I should know. I should know all about them. There's a whole thing that was left out. You should be a little angry about that. Right? It's like when you learn history in high school and then you learn real history in college. Right? I don't know if you guys have experienced that yet. It's a little bit, polished and made nice in high school sometimes. Okay, enough of this idea. The most important thing up here, by the way, is the idea of I, of course, and then this guy. I'm not saying that these are not important, but these are the ones that are going to happen the most often when we're doing problems. So let's take a step back. Let's see how I works. I is now a number. We have to investigate how does it act, right? Oh shit. So this is how does it act with itself? How does it act when you multiply it by itself several times? Thankfully, how does it act when you add? Well, what's I plus 3i? What's your gut say? You wish to God it is? It's freaking 4i. Thank God it is. Right? Right, so this is what we call pure imaginary. I'm going to still use this word because it's still used, but you all know it's bullshit. Now you do. It's not imaginary, but oh well. Okay. That's right. I got very few markers at work today. Ooh, look at you. Maybe you look. Yeah, a little bit. What if we mix real and imaginary? What does your gut tell you should happen? 4 plus 2i. Follow your gut.
It's just that.
It's just that. It's not 6i. I didn't add 4 more i's to 2i. So I acts like a variable. I like it. So if I have 4i plus 2i, that would be 6i all day long. This, when I mix real and imaginary, that's that word I keep using. This is a complex number, because it has a real and an imaginary part. Every number you've ever seen is a complex number where the coefficient of I is 0. It just has 0 imaginary part. So this is the real part, and this is the imaginary part. So every complex number is in the form a plus bi. So we just took our idea of real numbers. I don't know if you guys remember, if I even drew this, you have natural numbers, and then you have whole numbers, and then you have integers, and then you have rational numbers, and then you have real numbers, and now we made an even bigger freaking circle around all that, complex numbers, because they include the pure imaginary ones. All right. So continuing with this. Using your gut, right? It's a good place to use your gut here and not in, like, government or something. What does your gut tell you should happen when you add or subtract two complex numbers, like the one we just saw, 4 plus 2i plus 6 minus 7i? Yeah, totally. 10 minus 5. So when you are adding, subtracting complex numbers, I acts just like x. In fact, what else have we seen that's not really a variable, but it acts this way? Yeah, roots. And what is I? It's a root. So if I had 4 minus square root of 3 plus 2 plus 3 square root of 3, I could put the 4 and the 2 together. I could put the negative 3 and everything. All right? Same idea. Right? I is just a radical. It acts the same way as other radicals. It's just a weird-ass radical that we've given a letter to. Right? Okay, maybe. So what about this? Here, take a minute. You guys do this one on your own. Ha. It's not great, so who gives a shit? Just try it. Just do what you think should be the way this works. Let's see if you guys go far enough. So the first couple steps are treating I as if it's just another letter like X or A or M, right? So you get 10 plus 20I minus 6I. What do you get here? 12I squared. So you get 10 plus 14I minus 12I squared. Why am I not done though? Because I squared is negative 1. For some reason, people replace I with negative 1. That ain't right. Why does negative 1 need a variable? Just remember, I is square root of negative 1. I squared is negative 1. So I can go further than normal. And think about it. If I multiply a complex number by a complex number, the answer should be a complex number. I have to be able to put it in the form A plus BI. It ain't in that form. Because I squared is negative 1. So I get 10 plus 14I minus 12 times negative 1, because that's what I squared is. And then you get plus 12 plus 10, so 22 plus 14I.
Okay, can you tell me what I did wrong? I get what you did, I guess I don't get what I did. I did 10 plus 20I minus 6I minus 4I squared.
Oh,
And
you left the 3 out, maybe? Remember? 3 times 4? Yeah.
Yep, that's what I did.
Cool, okay. Yes?
What is that with the 12 I cubed?
It won't be. Do you see that? It won't be. If there was an I squared here, the first thing I would do is replace it with negative 1. That's why I said I, the definition of I, and I squared are the two most important things. Right? If you had to just forget all that shit and only take the most important thing out of there, the definition of I and I squared is negative 1. Those are the two most important things. Why? Because they're the ones you're going to see when you're doing algebra with complex numbers. I would never get I cubed, ever. How would I get an I cubed? Well, if this was I squared, I would get an I cubed. No, I wouldn't, because I squared is negative 1. I'd freaking replace it right away. Do you see what I'm saying?
Yeah.
So,
But hypothetically, what if it was minus 12 I?
all right, so hypothetically, if I said simplify this, oh crap. This is one of those things you have to have memorized.
Would that be
I cubed is negative I. So it'd be negative 12 times negative I, so it'd just be 12I. And I really wish, when I first learned complex numbers, they would have told me about this turn thing. Because I cubed is 1, 2, 3 turns, that's why it's negative I. That's why it's negative I. So if I were you, I might even draw that on my test and then just reference it. Right? Instead of memorizing the values directly, know this picture. That's even more beautiful, because then that's the concept. Less shit to memorize. More shit to understand. All right, maybe. This is brand new for some of you guys, so you gotta let it soak for a little while. This is kind of nice, though. I mean, adding, subtracting is just like as if it was X or something. Multiplying is just like if it's an X, but then when you have an I squared, you can go one step further than normal. X squared, I don't know what the shit that is. I squared, I know it's negative 1. I like it. So what's left? What's the one operation we haven't looked at yet? Division. So remind me, how would we divide, what you got, 5 divided by square root of 2 plus 3?
Multiply top and bottom by square root of 2 minus 1.
Cool. Let me remember what that was called?
Conjugate.
Conjugate. Kick ass. So any radical, does it matter that it was rad 2? Any square root of 7. You'd multiply square root of 7 minus 3. Right. Any square root down here, I'd multiply by the conjugate. So I multiply by rad 2 minus 3. Why do we do that weird shit? Because that's going to guarantee that the bottom becomes rational. So I get 2 plus 3 minus 3 gone, minus 9, negative 5 over negative 7, blah, blah, blah. A lot of blah blahs. So, how would I do this problem now? What you got, Jeff? 4 over 7 plus 2i. How would I divide that? Yeah, multiply by the, like I said yesterday, multiply by the complex conjugate, which is really the same damn thing. Right? What is I? It's the square root of something. Okay, it's going to act the same way as any other square root would act. So you multiply by what? So minus 2i, like the difference of squares pair for that, right? So on the top, you get 28 minus 8i. That's amazing. Bam. On the bottom, you get 49 plus 14i minus 14i. The middle terms cancel. That we created it to do that. So all the complex shit goes away. And what's 2i times negative 2i? Yeah, negative 4i squared. And of course, I squared is negative 1. So it becomes plus 4 on the bottom. So you get 28 minus 8i over 49 plus 4. 53, yeah. Oh, shit. So I is a radical. It's a square root. So it's going to do a lot of the same things that any other square root would do. But it's more than that. It's also something, it's the square root of negative 1. So that means I can actually do more with it. I can simplify I squared. Okay. Okay. I can't remember. I think that's basically all that's in section 10.7. Oh, one other little thing.
Just a question on the last problem.
Yeah.
Say that after they asked you to rationalize the denominator, for some reason they asked you to rationalize the numerator as well.
Oh,
Would you be able to factor out the number in front of the imaginary?
part of me would hope you realize that it would just go back to this. So either the complex shit's on the bottom or the complex shit's on the top. To go one step further, these are numbers. They're not quite the same as these are numbers too, but this is a certain breed of number. I don't know how to say. This is a division problem primarily. It's not a rationalization problem, to be honest. This is purely a division problem. So I want to divide these two complex numbers, and the answer needs to be a complex number. I like it. So I should be able to write this in the form a plus bi, and if I split this up, it totally is. Just a and b are kind of gross fractions, but oh well, they're still there. Okay. I like it. So this guy.
3i.
Yeah. So I could break it up as square root of 9 times square root of negative 1. Square root of 9 is 3. Square root of negative 1 is I. Just I is the way we choose to write square root of negative 1. Makes it a little easier to kind of work with it. So what about this here? This is where people make the biggest mistake. What you got, Jeff? I don't know, man. Square root of negative 3 times the square root of negative 5. I blame you for making this mistake. but it is a mistake.
We're multiplying it?
Sort of.
Square root of 59.
It'd be what now? So the wrong answer is the square root of 15. That's the wrong answer. And you're like, yeah. Because, what is this? This is I rad 3, isn't it? And this is I rad 5. Well, what's I times I? I squared, which is? Negative 1. Negative rad 15. That's the right answer. Because even if you did it just directly, wouldn't this be square root of negative 1 squared times 15? Do you guys see where that came from? No, okay. Negative 1 times negative 1, isn't that negative 1 squared?
So you can pull the negatives out?
Yeah.
Yeah, that's.
What's happening? Wait. All right.
So I'm confused where you're getting the I from.
Okay. Same place I got the I from here.
Okay.
Exact same place. What's the square root of negative 3? It's the square root of negative 1 times the square root of 3. True?
Okay.
And then what's the square root of negative 5? It's the square root of negative 1 times square root of 5. What's the square root of negative 1? I. So I'm not pulling a negative out. No. I'm simplifying the square root of negative 1. It's I. So it's a problem like this. Do I have to write it like this? No. You can. Hopefully you realize that the square root of 9 is 3. The square root of negative 9 is 3i. Where'd the I come from? It's the square root of negative 1 that's in there. I like it. I like it. So here again, I just get I rad 3 times I rad 5, which is negative rad 15. So you just want to be careful about if there's a negative under the radical, you want to rewrite it in I form, so if you have to do extra shit with it, you'll do it correctly. If you just think the negatives kill each other, they don't quite. Not really. There's 2 of them, so it should have one of them out here, right? What's the square root of 2 times the square root of 2? 2. So what's the square root of negative 1 times the square root of negative 1? There you go. So the negatives don't kill each other. Since they're in radicals, there gets to be a whole one of them outside. The same way as any other number. Why would negative 1 not get to be treated the same way? Right? It's a little numberist. Yes?
You had 3 terms, so like it's negative, rad negative 3, rad negative 5. If there was another one,
Yeah,
would
sure.
you be getting an I cubed at the end of it? Or would
Yeah,
you mess with
so,
that multiplication a lot?
So you get, if you had square root of negative 2, square root of negative 5, square root of negative 7.
Yeah.
So this would be I rad 2 times I rad 5 times I rad 7.
Right.
I times I is negative 1 times I is negative I. So you never have to bring in, to be honest, you can always just pair them up and then replace it with negative 1, pair them up, replace it with negative 1. When you're doing algebra on these things, you never really have to end up with a higher degree. Oh, well, covering my ass, I'll say almost now. Can't think of a way right now, but even knows, it might happen. And then you get inside 7. I like it. But the key is, square root of a negative number, you want to rewrite it with an I so that you do the correct algebra to it. That's the key. So an I, writing it as an I actually helps us do things the right way. This is an easy example of why it's easy to make a mistake if you don't do that. Okay. How do you solve this again? Somebody remember? I think we talked about this. You could subtract 16, factor. What's a more direct way to do this? Take the square root, and what is it you got to remember when you write the square root? Plus or minus, to cover your ass for the fact that it's going to be 2. When do you have to do that? When you're taking an even root, right? So this would be x equals plus or minus 4. So how do you, now let's go ahead and solve this. We can do that now.
3
Plus or minus 3.
Yeah. So you take a square root plus or minus of x equals plus or minus square root of 9 is 3, square root of negative 1 is I. Some of you guys might realize That means we can factor sum of squares now, because we've expanded our number understanding to include these complex numbers. Yes, sir?
Why do we need plus or minus for the 3i?
Because there's going to be two answers, right? And this is a semi-shortcut, to be honest. Watch, I'll show you right now. You ready? On this one, x squared equals 16, I could have written it as x squared minus 16 equals 0. Factor, I'm going to get two answers, right? X equals plus or minus 4. If I do this one, bring the 9 over, factor this, and some of you guys are going to be like, I don't know, some of you guys are not going to understand my point. You're going to leave like, one day he says you can't do it, next day you go, no. Now we know more numbers, we're able to do more shit, right? If we didn't know negative numbers, we could only do so much shit. We couldn't do other shit. So now, x, I know that 3 and 3 are never going to work. But do you see how putting them in is going to change the sign? If it wasn't in there, what's the sign going to be on the 9? Negative. If we put I and I, isn't that going to make it I squared and make it back to plus 9? So any sum of squares can be factored using imaginary numbers.
So when we factor, we can use the imaginary number, right?
Yeah, if I ask you to factor x squared plus 9, that's how you would factor it. And now do you see I get the same two answers, right? X equals negative 3i and positive 3i. Bam. I like it. And it's not that big of a step from like, how do you factor x squared minus 2? You can do it. What goes here? In there.
2.
Why do we put a 4 here? Because 4 is the do it. Square root of 16. All right, what's the square root of 2? I just said it. Do you see that? Why do we normally not go this far? Because we normally like to stop when they're nice integers. It's just sort of a convention we've used. In pre-calculus, you're going to stop that stupid shit. You're actually going to go this far, right? And you're going to go this far. I like it. Because we do like to get down to x. Because now I can just see the answer. If this was equal to 0, I can see why it's plus or minus rad 2. I can see both parts and where they come from. Okay, maybe. Let's see, anything else weird in here? No, okay. Sweet. So I'm always curious if anybody out there starts to realize complex numbers we've just added. For some of you guys, I don't know, have any of you never seen it until today? Complex numbers, imaginary numbers. Okay. For some of you guys, your worldview of numbers have just expanded like insanity. Right? I mean, it's just like you didn't even know these things existed. And now there's a question about, well, how much can you do with these things? I'm not even going to tell you how to do this, but what about like the square root of I? I don't freaking know. Cube root of I? That one I know. I could do that one. I have to think about it for a while. Anyway. Right? And you start to wonder, what else can you do with these things? That's a little bit beyond the scope of what we worry about. But we've just introduced the idea of these brand new set of numbers. It's sort of like teaching somebody negative numbers for the very first time. Just imagine all the shit they can do now that they really couldn't do before. Well, you don't even know what you can do now. Right? Okay. If you have a graphing calculator, by the way, you might want to read the manual about it because it can handle complex numbers. Right? Which might show you why I need you to show your work. So if you learn that on your own, because I'm not going to show you, you could use it to check your answers. That's great. But I need to see the work. Okay. Let's see. Maybe now is a decent time to take a break. What do you think? Did you notice the clock's working now? Mm-hmm. So now I'm going to get a lot more of this while I'm teaching. Just telling everybody. All right. So come back. Let's say 10 till. Just a short little 15-minute break. I like it. Yes? What do you mean? Yes. Oh! No, you can have that just to see what it looks like. Whatever you make on the test will take the place of that quiz grade also. So you can just have that to see what it looks like.
So not allowed to take it.
No, no make it. Well, just to keep it. Yeah, yeah. You can keep it. You can see it. You can even work it out, and I can tell you if you got it right. But trying to do like make a quiz is just too much to keep track of. Yeah. Sure.